Hi, folks. Welcome to this talk about easy improvements in your microservices architecture. I'm NICOLAS FRANKEL. I've been a former developer, team lead, and architect. I started my career 20 years ago, and for like 18 years of them, I was roles. And now I'm a developer advocate, and I'm quite used because I was a consultant to enterprise tax. I work for a company called Hazel. Hazel has two products. The main one is an in-memory data grid, and I will talk about the in-memory data grid in this talk because I will use it. And the other product is Jet, and it's a stream processing in-memory engine so that you can manage your data, transform it just like you would be, for example, for Java 8 streams, but distributed over the network. Microservices. Who doesn't do microservices? I guess a lot of you do microservices. And in general, the problem is that those microservices initiatives, they are driven by technical considerations. So here is the definition of microservice architecture. It's not from me, it's from Martin Fowler. So if you disagree with this definition, please bring it up to him. But since it's a good reference, I just copy-pasted this point. And you can see that you can, if you already have a microservices architecture, then you probably go from one step to the other, and you say, yeah, check, 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 check. And you see the 8th point is organize your microservice around business capabilities. Now, it's different than just technical stuff. You can still check. The last point is about products and not project. And I believe this is one of the main issues. A lot of people want to say they do microservices, and again, they see it from the technical point of view, but microservices are an organizational solution to an organizational issue. And in general, if you just manage the technical stuff, you are not doing microservices, which is fine. I mean, you don't need to have microservices on your resume. And the last point here is product and not project, and the difference being that projects that have start time, and they have end dates. And between these two dates, you need to spend some budget and to deliver some functionalities, where our product, it's the same, but the budget is probably yearly. And of course, you still need to deliver something, but there is no end date. So it goes unlimited in time. And when I do this talk on site, I ask, hey, who is doing microservices? At the beginning of this slide, probably there are 50% of people who tell me, yes, we are doing microservices. And when I describe this issue that it's about product and not project, then at the end, it's probably 1 or 2 people in the room, whatever the size of the room. Generally, it's a 50% or 100% size room. And yeah, only a few of them are organized around products. Again, it's fine. You don't need to do microservices. You can just do like service-oriented capabilities. That's perfect. But since everything is about microservices, that's also in the title of my talk, it's just to attract you, to trap you. Let's talk about one of the benefits of microservices. And promoters of microservices, they say that, yeah, one of the benefits of microservices is scalability. So imagine I always use the same example of an e-commerce shop. And an e-commerce shop, you will probably have like a catalog browsing service. You will probably have a checkout service. You probably have a cart service. You probably have a payment service. And since an e-commerce microservices architecture like implements a shop, then there is a sales funnel. So you will have a lot more people using the catalog browsing service than the payment service. And if you have a monolith, if every one of those capabilities, they are in the same deployment units, and you want to scale according to the most used capability, which in this case is the catalog browsing one, then you will need to duplicate your whole deployment unit, your whole monolith, just because of the scalability issue that you encounter on the catalog browsing capability. Whereas if you have separate deployment units for each capability, then you can scale them accordingly, and probably the catalog browsing capability needs to be scaled much more than the payment one, because a lot more people will be using the first than the later. Makes sense, I hope. And this is also a joke that I do in general. Of course, here it's less interesting because I cannot see the look on your face, but on the left, you have a UML diagram that describes something, and on the right, you have the same UML diagram. And actually, you can say, yeah, on the left, it's a UML diagram for an API call, and on the right, it's a UML diagram for a microservice, or at least a HTTP service call. And yeah, from a design point of view, from like an abstracted point of view, they are both the same. An architect will say, oh, you know, we just do the data diagram. I can tell it because I've been an architect. We just do like the boxes and the rows, and it's up to the developers. It's an implementation detail. But actually, it's very wrong. It's not only an implementation detail, it has huge consequences. So it's an implementation details, but it has huge consequences on your performances. Because once you start like going outside your JVM, when you start doing network calls, then your application becomes a distributed system. And the problem of distributed system is, first, they will be slow. Anyway, they will be slow. So if you start having performance issues and you say, great, your performances. I mean, it's not hard to understand that if you make an HTTP call, it might be 2 or 3 orders of magnitudes longer than a call inside the same JVM. And probably you know about those fallacies of distributed computing if you don't know about them, but even if you know about them, it's very good to just print that and put it in your office, or now on your door in your like private office at home if you have one, or where you work, because that's very easy to fall into this trap that, yeah, we do a distributed call and everything is fine. The first point is the network is reliable. You make a call inside your JVM, and it has to output. Well, you get the result, or you've got an exception. And in both cases, you know how to handle that. But the problem is, if you start doing HTTP calls, then you can make a call, and of course, you can get the results. Of course, you can get, well, not an exception, but an error message, an error payload. But what can also happen is nothing. So you make a request, and you will never get the response, or the response will come back too late. And the hardest problem is that if you make a request and you will never get the response, is you are not even sure that your request reached the server and it's starting doing its job or not. And that's the problem with the network. It's not reliable. As I mentioned, latency is not 0, and blah, 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 and so forth and so forth. So now you can see that my nice diagram that I just used before becomes much more complicated. And because now we understand that we have a lot of layers between A and B if you are using the network. And it can be like layers in your application, it can be layers on the network, and it can be ISO layers, it can be a lot of stuff. And it's even worse than that, because now we must also get the response. So that is really what you need to design. And at every layer, of course, it can fail, it can succeed, or it can be just lost. So because we are in this world where we don't know what can happen, we need something that needs to be reliable. And the issue, as I mentioned, is if you make a request, you have no response, it can be a problem. Imagine you have a customer, commerce shop, he has put everything in the cart, he has gone to the checkout page, he has entered his payment details, and just before that, you need to do some pricing, just to be sure that the price is correct. You cannot just say that the pricing microservices fails and the customer is left hanging. I mean, that's the worst you can do. In e-commerce, you need to sell. So the idea is when you get the prices, and probably it will work at some point in time, well, at least I hope for you, because if it doesn't work, it never works, you have other issues. If it works at least a couple of times, the majority of the time, we will keep this data locally. And so if the next time we try to get the data and we don't receive an answer, a response, then we will just read the data from the local cache. So that's something to understand. Caching is helping a lot, but you're making a trade-off. You're making the trade-off that speed of accessing the data is actually more important than the data to be up to date. And most engineers, including myself, we don't like that. We say, no, we want the exact data. But then you come to the business and you ask them, hey, do you prefer to sell at a slightly wrong price or not sell at all? And yes, the idea will be that they will probably want to sell at all costs. And of course, even if the price is slightly wrong, it's not that important because, of course, sometimes you might sell a bit lower, sometimes you will sell a bit higher. So at the end of the day, it will be averaged anyway. But that's very important to understand. If you want to make mathematical computation, caching is not good, well, in most cases. If you want to improve your performance, then caching is good. And of course, you know that there are two hard things in computer science: cache invalidation, naming things, and off by one error. So that's an issue. Caching is hard. I mean, cache invalidation is hard. If you are like me, if you are an engineer, and you probably wanted to use cache at some point, you probably thought about using a hash map, and you use the hash map. And that's what I did, but it's really, really bad. Why? Because the problem of the hash map, it has no limits inside. So you put stuff in your hash map, it grows and grows and grows. If you put enough stuff, you probably get an out-of-memory error at some point. So please, if you want to use a cache, if you want to use a hash map as a cache, don't do it. That's the first service you can give yourself. You just use a professional caching solution. It can be Hazel cost, it can be another one. I don't care, but please just make your life easier. So now we use a professional caching solution, and not only does it able to set a limit so that the hash map is bounded, but actually there you can probably plug and play an eviction strategy. So you have a limit and you have reached the limit, so you have put every item you needed into your hash map, but there is still one more item that needs to go into it, and the limit has been reached. So which item do we remove from the hash map? So that's where an eviction strategy comes in. And an eviction strategy tells, hey, which item do we remove from the hash map? Is it based on the least recently used? Is it based on the least frequently used? Do we have some additional priority metadata that we want those items to stay more in the cache than other? It's up to you. Again, professional caching solutions, they all provide something for that. Also, when you want to put an item into the cache, probably you don't want it to stay there forever, because at some point you want, for example, the price to be refreshed. So the idea is to say, how long will the item stay into the cache? So that every time you put, you need to attach it a time to live. And there is a background thread that wakens at a regular interval and say, oh, it has lived too long, I remove it from the cache. And that's where an in-memory data grid comes in, because an in-memory data grid is just like distributed data structure over the network, so as hash map, queues, list, whatever. We've added power, because distributed compared to local means that you can do some replication, so that if you have one single JVM, you have your cache, for whatever reason, the JVM crashes, the cache is gone because it was in the memory. Now, if we was in the memory, now capability of an in-memory data grid is that you can actually shard the data, because perhaps the data is too big to store to fit into a single JVM, even if you have a lot of memories. So you will need to short across several JVMs, and you can have both. So you can have like shorting and replication. So this is the benefit of an in-memory data grid compared to a local cache. And in microservices architecture, we can use cache in a lot of different places. So here is a choice of three. First, database access. Second is HTTP calls. And third is session data. So let's see how it works. First, I believe that if you are a Java developer, even a junior one, you have been probably, you know about Hibernate. Even if you don't like it, even if you don't use it, you probably know about it. And Hibernate make the mapping between your objects, your classes, and the tables and the rows. It's super widespread. It's so widespread that it's a GPA implementation, that it's the default implementation in Spring Boot, for example, if you want to use GPA. And Hibernate has two caches, two levels of caches, and they are named, well, without any imagination, level 1 cache and level 2 cache. And the problem is that the level 1 cache is implemented by default, so you get it for free, but it's bound to the session object. How does it work? Every time you will do something, like get the data or whatever, then you will like use this cache, which is good. The problem is this session object is probably very short-lived. Like if you are using a web framework, what generally happens is you make now you create the HTTP response, and your session is gone because the next HTTP request will recreate a session object from the session factory. So this is very useful, this cache. It's implemented by default, but actually you don't cache much. There is very, very low chances that you actually use the cache. The second level cache is actually much more useful, but it's not on by default. You need to enable it. And there are multiple integrations available. And how does it work? It's a read-through cache and a write-through cache. So read-through is very simple. If you want to load something from the database, Hibernate will look if the cache contains the key that you want to load. And if it doesn't contain the key, it will load it from the database with the value and put that into the cache. If it contained it, it returns the key and the value. And write-through is the same, but it's even simpler. It's just like when you update the database, you update the cache value. So let's have some demo. And here I've created a project, and there is something that I need to ask is how long do I need to talk? Because otherwise I will talk and talk and talk and talk, never ending. So please, I didn't check. Can you, Eva, tell me how long I can talk? Don't be afraid to tell me. I don't see the chat, so please, I'm listening to you. So I've created a Spring Boot project here. It uses Spring Boot Starter Data GPA. It uses Spring Boot Starter Web. I'm using Hazel Cost for the cache. I'm using the integration of Hazel Cost and Hibernate. And I'm using the H2 database, which is an in-memory database. So that's pretty stupid. That's probably what you don't want to do in real life, but it's useful for me because everything is self-contained. Like caching in memory, something that is read from memory, not useful. But again, very useful to demo it. So I have this person controller, and I can get all the persons, or I can get one single person by its ID. Then I have this person repository, and it just extends this GPA repository. That's the super cool with Spring Data GPA is I have a lot of default implementation that I've written for me. And I will start the application. And I will curl HTTP. Curl HTTP localhost 8080, and I will make P1. So the first thing to check is that actually I have enabled the Hibernate statistics. So when I start the application, well, the Hibernate statistics are my first requests. Oh, it's D, it's not P. Here is my first request. And yep. How long?
Hello, you have 30 minutes.
30 minutes from now.
Yeah.
Perfect, thanks a lot. So here I have, nothing was in the cache. So actually I did some like SQL requests. There was nothing in the cache, so I have a miss. It did the request and there is a put. Now if I do it again, we can see in the log that actually I have a hit and I didn't do anything regarding SQL, which is pretty cool. That means that, yes, I read directly from the cache. And what is even better is because there is something in Hibernate called the query cache, we can query all entities, we can query all entities, and now everything is in the cache. So now if we check, for example, the third one, pretty useful, I believe. Now, if you want to be even faster, right now we are doing read through. So every time it's synchronized and we need to go to the database. What we can do is we can remove completely Hibernate and GPA. You can only interact with Hazelcast itself. And then Hazelcast will have some kind of listeners to write or to read from the database. And you can make it async. Of course, async will make it like faster for you, but there is no guarantee about the data. So again, it's a trade-off. Do I want to be consistent or do I want to be fast? And where do I put the cursor? Second improvement, HTTP and cache, which was my talk about the microservices architecture. You could say every time I make an HTTP call, I will cache the results. And you can do that manually, but actually there is a Java API for that. There is something called JCache. This is a specification and you have multiple implementation. Hazelcast is one of them, but you have others. And the good thing is that the JCache is integrated with Spring. So again, my e-commerce architecture example, I want to cache the pricing in the checkout microservices. Every time I want to keep it. So let's have some demo. I will stop it. I will just use Git. So the first thing that can be said is here about the Hibernate example. The configuration is pretty easy. You just say, I want to use a second level cache. Other thing that you want to get all the data and put it in the cache when you do a query for find all, you use query cache. And here, this is the Hibernate configuration for Hazelcast. And the only thing that you need to do afterwards is to provide something called config, which basically tells Spring, hey, like here you see I put into the context a config object, and Spring will detect that, and it will create a Hazelcast instance. So now I will showcase it. So I won't showcase it through JCache. I will directly use Spring Cache. So there is also an abstraction in Spring called Spring Cache. And what it can do is you can use Spring Cache and say that the implementation of Spring Cache is JCache and that the implementation of JCache is Hazel cost, which basically makes it like too many layers to be really interesting. So what I do, I just say, okay, I will just use, like here, I will use Spring Cache and Hazel cost is also a Spring Cache implementation. So that's very easy. I have added another controller, and this controller uses something called a caching service. And the caching service like uses the person repository, and every time I do a get, it will put the entity in another cache called the service cache. So it's just a proxy controller, and this proxy controller like has a cache between itself, like the controller, and the repository. So now I will start this application. And I will need to query. So I need to remember that this is OR now. So I will query for OR3. Now I am a bit of an issue because I want to prove you that there is some caching involved. So in all the rest of this code, of this talk, everything is free and open source. Here, what I will show you is not open source. It's free up to 2 nodes, and it's called the Hazel costs manual center. I hope I remember the context correctly. No NC start, HZ NC start. It's 8081, not 81. Nope, it's P. I need to bind to a port that is not 8080 because by default it's 88. And now I can get here on localhost 8081, and I can log in. No, I don't want to set the password. And here we can see that we have 3 maps. We have the database one, of course, but I already showed you that it was used because of Hibernate statistics. And I have this new one called service one. And we see there is 1 entry. There was 1 get. There was 1 set. And now if we start like calling doesn't be changed, but now there is 1 hit. And we can see also here the number of entities in this map. Now I cannot do the same trick as I did before to have all the entities into the cache. Here there is an issue about the Spring framework that is like tagged as won't fix. And the issue is here with those annotation, it's easy to say here the key is the ID and the value is the person. But if we have the get all persons, then because we are not using Hibernate, there is no way to know about the form of the data inside the lists. And right now, Spring won't fix this issue, so there is no way to have like a find all, get every entity and get it into your cache, unfortunately. But that's life. And the final improvement is session data. We all know and love stateless applications, but unfortunately, most applications, they are not stateless. Most applications, they store something in the session. Like, again, with the e-commerce example, the cart in general is not stored in the database because it would be too long to every time there is a request to make a query to the database. In general, the cart is stored in the session and it's accessed instantly. And so because the application is not stateless, because we want our user to always be directed to the same node that has the cart in memory, then we have a load balancer in front, and the load balancer is configured with session affinity. So The first time there is a request, there is an association when here the Tomcat returns the response, then it returns as well a JSession ID. And so the load balancer in front associates the JSession ID with this specific Tomcat. So if there are subsequent requests, then they're all structure in the world, Tomcat will go down at some point. And so if the customer gets back to here and Tomcat has been down, the load balancer will direct us to another Tomcat, which unfortunately has no session data, has no associated, so has no cards, and the customer will see his cart empty, and probably he will be very unhappy, and we will go to another e-commerce shop. So how do we solve that? Well, the idea is to replicate the session data across all nodes in the cluster, all Tomcat nodes. And if there are any standards, well, no, there are no standards in that case. So what do? Well, we have integration. Hazel can help you there. We have different levels of integration. The first is if you are not using anything standard, you can use a web filter-based integration. So in your application, you define a web filter, you configure it, and we will do session replication. If you are using already Spring Session, then you know about all I've told before, and Hazelcast is actually a Spring Session implementation, sorry. Or if you are using Jetty or Tomcat, you can integrate Hazelcast through configuration of Tomcat or Jetty directly, which can be cool because that means that during development, the developer doesn't care that there is session replication. It's completely transparent to him, and it's the ops part or the DevOps, if you want to call them DevOps, that will do the configuration in production or in the environments that they need to do. Of course, if you are using Tomcat embedded or Jetty embedded with Spring Boot, you can also configure it inside the code, which I will be doing because it will be easier for me. So let's get to the latest stuff. Class, I have a session data controller, and the session data controller, every time it receives a request, it will use a session data handler, and I will show you what is a session data handler afterwards. This session data handler will actually get data from the session data stuff. It will read one attribute and it will increment it. So this is my session data handler, and I will check that I will have an existing session data object in the session, and if I don't have it, I will create it, and I will increment its count, and I will put it again into the session. And session data is very easy. There is one stupid counter, and there is a string, an ID, which will be the G-session ID. And meanwhile, I will do I will try to deploy this application, 2 nodes application, on a Docker Compose file. Docker Compose file, there will be a load balancer, and there will be two Tomcat nodes. And because I don't want to switch off one of the Tomcats, what I've created is a HR proxy load balancer with a specific configuration. And basically, this configuration allows me that every request goes to one node, then to the other node, then to the first node, then to the second node. So I'm actually forcing the fact that there is no session affinity, that it will always be like round robin. And so if it works as expected, which I hope, because our demo that fails are already hurting to me, well, if it works as expected, I will go to the load balancer and ask, hey, give me session data, it will give me 1. And the second time, it will give me 2. And the third time, it will give me 3. If I didn't configure it correctly, if there is no session data replication, then I will ask the first time it will go to one node, it will tell me 1, then it will direct me to the other node, and the other node will tell me 1. Then I will ask a third time, it will tell me 2, and then 2, and then 3, and then 3. So I hope it won't happen. So let's see how it goes. And here I should have stopped that. And now I will be doing this Docker compose up. So now it's starting the whole well, infrastructure. Both applications that are starting, they are just like the application containerized. I containerize them through the G plugin, but that is not very interesting to you. I didn't create no Docker file. Now both servers are up and everything should be going as expected. So now I will go here and I will do local hosts, and I must remember that it's the load balancer and not section. Now count 1, and now if I refresh, it should be count 2 if everything is fine. Count 2, count 3, count 4. Yes, I have session replication. And how did I achieve session replication? I achieved session replication very easily. I just went to my main application, and here, as I mentioned, I will use this customizer to customize the web server factory. And I add a context customizer. So I create this Hazel cost object, Hazel cost session manager. Here, because I have explicit randoming, I set it sticky to false, but normally you shouldn't do that. And then I say, hey, I will use the Hazel cost instance that's already existing and sets the manager to the Tomcat context, and it's done. And that's the only thing that you need to do actually, which is pretty cool. Like in a few lines of code of configuration, we just implemented session replication. So this is what I wanted to tell you. As a reminder, please, there are a few key takeaways from this talk. The first is, please don't do microservices because you have performance issue. You do microservices because you have scalability issue in your organization and perhaps scalability issues regarding the technical stuff, and you want to scale horizontally. But you will lose performance at first. If you lose performance, then caching is fine. And of course, there is a trade-off, and the trade-off is data will be stale. So you need to think about, hey, how much stale do I accept my data to be? Hazel cost can help you in 3 different areas at least. Database access, we have integration with Hibernate. HTTP calls, we have integration with JCache and Springcache. And session data, we have integration with at least Spring Session, but you can also do, as I showed you, and do direct Tomcat customization. So thanks a lot for your attention. Thanks a lot for your attention. To the GitHub repository. And if you want to know more about Hazel cost, or you are happy or not so happy Hazel cost user and you want to interact with us, please join our Slack. And so now is the end, and perhaps there are some questions. So I will just go back here and go back here and stop sharing my screen. And I will be happy to have your questions now. Are there any questions? If there are no questions, that's always a bit disturbing, because either it was a very good talk and it doesn't deserve any question, it was very clear, or it was very bad and you don't want to shame me publicly. So Stephen, thanks, Stephen, I appreciate that. Stephen said that was excellent, so which is good. That's good feedback. So feedback is appreciated, even if it's not a question. But we still have a couple of minutes, so if you have questions, I will be happy to try to answer them. So I will count to 5, Would Hazelcast help with caching in conjunction with Mulesoft API environment? So to be honest, I don't know about Mulesoft at all, but Hazelcast is just a cache. So if you want to put something in the cache, well, we have API for that, REST API or Java API, or we even have C, C++ API, Go APIs, Node.js API, Python APIs. It's up to you. So if Mulesoft integrates with any of those, then you can use Hazelcast caching, yes. Nicoletta, thanks a lot. It was indeed very clear talk, really enjoyed it. Thanks a lot, Nicoletta. I appreciate that. I appreciate your feedback. Bongo also, thanks a lot. Any more questions? No more questions, so I will count to 5. And if at 5 I don't have more questions, I will thank you a lot for your time, and I will wish you to enjoy the rest of the conference. 1, 2, 3, 4, 5. Thanks a lot. Have a great day. Stay safe, and yeah, enjoy your vacations if you have. Probably you have. And yeah, I hope to see you in person at some point in the future, even if it's near. Bye-bye.